Hello, this is Xinru. In this video, we are going to take a look at question 1382, balance a binary search tree. So in this question, we have to balance a binary search tree with the same node values. And first, let's review what is a binary search tree. A binary search tree is a tree that has every root value has two nodes. The left node is less than the root value and the right node is bigger than the root value. And a balanced binary search tree is a tree that the depths of the two subtrees of every node never differ by more than 1. So as you can see in example 1, the first tree is not a balanced binary search tree because node 2 and node 4 as node 4 is the depths of node 4 and the depths of node 2 are different than 2. Therefore, it is not a balanced binary search tree. And how are we going to convert it to a balanced tree? So what we need to do is we need to first decide what should be the root value. Because if you choose a root value that is on the left, if you choose the smallest value as the root value, the tree will not be balanced. And at the same time, if you choose the biggest value as the root value, the tree will not be balanced as well. So what we need to choose, the root value should be the middle of the smallest value and the biggest value. Therefore, that comes our algorithm. First, we need to store the nodes from the smallest to the biggest value. So to store nodes in order, then we have to traverse this binary search tree in order. Therefore, we have to write our first function as store nodes function. And in this function, what we need is an array called nodes that will store all of our nodes in order. And we also need a node reference. We will use this node reference to traverse through the tree. And if node doesn't exist, what will we do is we will return as that means we have reached the end of the node. And then what will we do is we will call this function as this is an in-order traversal of the tree. So store nodes and node dot left store and nodes dot push as node and store nodes and node dot right. So we will traverse through this binary search tree this way. So we will get our nodes and from the smallest value to the biggest value. And after we have this nodes array, what will we do is we will start building the tree. So as I mentioned before, we always need to find the mid value. So what will we do is we will need to use recursive function again for this task. So we will create a function called build tree. And in this function, what we need is first we need our array nodes, and we also need the left value and the right value. So we need our start value and the end value. And basically, if start value is bigger than the end value, that means because start value is the left value, it should not be bigger than the end value. And if that happens, it means we have reached the end of this function. So we will just simply return null. And next thing we need to do is we need to find the mid value. And the mid value should be start plus end divide 2. And here we get our mid value. After we get the mid value, we will use the mid value to get our node. And node equals to nodes of mid. So next part is tricky, is that after we get our node, then we start building the tree from our node. So as you can see, the start variable and the end variable we first given to this build tree will be the start, will be the smallest value and the biggest value of the entire tree. And so the node we will find in the mid should be the root value of our new binary search tree. Therefore, in that case, if we keep if we want to build a new tree, we should start building from the node we are getting now. Therefore, we will call this recursive function from this node. So node.left is equals to build tree of nodes, and the start value should be start and mid minus 1. And node.right should equals to build tree of nodes and mid plus 1 and right. So in that case, we will start building this building upon this node of our new tree, and the nodes left will, so in the next recursion, nodes left will be considered a root, and we will start finding the mid value from the left part, and then we will also assign the mid value as the left node of our root node. And eventually, all we need to do is just return node. So after we get this two functions, now what we can do is we can first initialize our first nodes array. And then we will start build. Then we will first call this store nodes and to process this nodes array. And after this function, our nodes will contain all the nodes from the smallest to the biggest. Then all we need to do is start building tree. So our new tree will be, let's call it our result, will be build tree of nodes from 0 to nodes.length minus 1. Then our build tree will get into work to find first the mid value of the entire tree, then the mid value of the left part of the tree, and then assigned to the our root node's left node, and then it will find out the mid value of the right part and assign it to the right node of our root node. And doing this recursively, it will eventually form our new balanced binary search tree. So now we return our result. So it says node is not defined. I should call nodes as an array. So the key point is that we need to find out how do we determine the root node. The way we determine the root node is that we need to figure out what's the left boundary and what's the right boundary. And for every node, if we take them as a root node, the left boundary and the right boundary are different. Therefore, we have to use a recursive function.